transportation safety and economics. Highway safety. There are 5 major safety programs that are addressed by state in developing a safety management program. 1 is coordinating and integrating road-based safety programs. Number 2, identifying and investigating hazardous highway safety problems and roadway location features. Number 3, ensuring early consideration of safety in all highway construction programs and projects. 4, identifying safety needs of special user groups in planning, design, construction, and operation of highway systems. 5, routinely maintaining and upgrading safety hardware, highway elements, and operational features. Issues involved in transportation safety. Crashes or accidents. Accidents is commonly accepted word for an occurrence involving one or more transportation vehicles in collision that result in property damages, injury, or death. The term accident implies a random event that occurs for no apparent reason other than it just happened. Crash implies that collision could have been prevented or its effect minimized by modifying driver behavior, vehicle design, called trustworthiness, roadway, geometry, or traveling environment. What causes transportation crashes? In some cases, the answer may be simple one. For example, the cause of a single car crash may be the driver fell asleep at the wheel, crossed the highway shoulder, and crashed into the tree. In other cases, the answer may be complex, involving many factors that, acting together, cause a crash to occur. Based on this illustration and other similar cases, it is possible to construct a general list of categories of circumstances that could influence the occurrence of transportation crashes. If the factors that have contributed to crash events are identified, it is then possible to modify and improve the transportation system in the future with the reduction or elimination of the crash-causing factor. A safety transportation system is likely to resolve. Factors involved in transportation crashes. 1 is human factors, driver-operator action. 2, the vehicle condition. 3, the roadway condition. 4, the environment.
Strategic highways safety plans. The purpose of this plan is to develop a process to which each state would identify its key safety needs, such that investment decision can be made that will result in significant reduction of highway fatalities and serious injuries on public roads. Suggested activities that could be included in these plans are: first is to gain leadership, support, and initiative. Next is to identify a champion. Next is to initiate the development process. Next is to gather data. And after gathering the data will be analyzed. Next is to establish working group. Next, bring safety partners together. Next is to adopt a strategic goal. Next is to identify key emphasis areas to form task groups. Next is to identify strategies and countermeasures. And last is to determine priorities for implementation, right? SHSP.
Highway Safety Improvement Program at the process level. Planning component. The planning component of the HSIP consists of 4 processes as shown in the figure. These are: first, collecting and maintaining data. Second, identifying hazardous locations and elements. Third, conducting engineering studies. And lastly, establishing project priorities. Previous figure shows that the information obtained under the planning component serves as input to the 2 other components, and that results obtained from the evaluation component may also serve as input to the planning component. In the implementation and evaluation components, for implementation, it involves scheduling selected projects and implementing the highway safety improvements selected. The evaluation component involves determination of the effect of the highway safety improvement. This involves the collection of data for a period after the implementation of the improvement to determine whether anticipated benefits are actually occurred. Effectiveness of safety design features. There are different crash types. These are collision with trees in hazardous location, head-on collisions, unsignalized intersection collisions, collisions on horizontal curves, collisions involving pedestrians, and lastly, collisions at signalized intersections. There are also objectives and strategies. Collisions with trees in hazardous locations. Develop, revise, and implement guidelines to prevent placing trees in hazardous locations. Develop moving and vegetation control guidelines. Remove trees in hazardous locations. Shield motorists from striking trees. Modify roadside clear zone in vicinity of trees. And delineate trees in hazardous locations. For head-on collisions, install centerline rumble strips for two-lane roads. Install profile thermoplastic strips for center lines. Improve wider cross-sections for two-lane roads. Provide center two-way left turn lanes for 4 and 2-lane roads. Relocate total 2-lane roads with lane and shoulder to include a narrow buffer median. Use alternating passing lanes of 4-lane sections at key locations. Lastly, install median barriers for narrow width medians on multi-lane roads. For unsignalized intersection collisions, implement driveway closures or relocations. Implement driveway turn restrictions. Provide left or turn lanes at intersections. Provide offset left turn lanes at intersections. Provide right and left turn accelerated lane at divided highway intersections. Restrict or eliminate turning maneuvers by signing or channelization or closing median openings. Clear side triangles on stop or yield intersections. Clear side triangles in the median of divided highways. And lastly, change horizontal and or vertical alignment of approaches to provide more side distance. For collisions on horizontal curves, we must provide advance warning of unexpected changes in horizontal curves. Enhance delineation along the curve. Install shoulder and centerline rumble strips. Provide skid-resistant pavement surfaces. Improve or restore super elevation. Widen roadways. Modify horizontal alignment. Design safer slopes and ditches to prevent rollovers. Relocate objects in hazardous locations. Delineate roadside objects. Improve design and application of barriers and attenuation system. For collisions involving pedestrians, we must also provide sidewalks, walkways, and curb ramps. Install or upgrade traffic and pedestrian refugee islands and raised medians. Install or upgrade traffic and pedestrian lane signals. Provide crosswalk enhancements. Signal to alert motorists that pedestrians are crossing. Eliminate screening by physical objects. Implement road narrowing measures. Install traffic calming road sections. Install traffic calming intersections. For collisions at signalized intersections, employ multi-phase signal operations. Optimize clearance intervals. Employ signal coordination and employ emergency vehicle preemption. Provide improved left turn and right turn channelization, and improve geometry of pedestrian and bicycle facilities. Revise geometry of complex intersections, clear side triangles, lastly, redesign intersection approaches.
There are 5 design features to be considered. First, access control. Access control is defined as some combination of at-grade intersections, business and private driveways, and median crossovers. For any given highway, access control can range from full control, such as an interstate highway, to no access control, common on most urban highways. The reason why access control improves safety is because there are fewer unexpected events caused by vehicles entering and leaving the traffic stream at lower speeds, resulting in less interference with slow traffic. Next is alignment. The geometric design of highway involves 3 elements, and these are vertical alignment, horizontal alignment, and
Vertical alignment is influenced by consideration of terrain, cost, and safety. Horizontal alignment is influenced by design, speed, and super-elevation of the curve itself. Next is cross-section. One of the most important roadway features affecting safety is the highway cross-section. Cross-section elements, including through and passing lanes, medians, and left turn lanes, may be added when a two-lane road is inadequate, possibly improving both traffic operations and safety. Safety improvements in the highway cross-section are usually focused in two-lane roads, with the exception of clear zone treatments and medians designed for multi-lane highways. As you can see, there's an original ground, then side slope, then shoulder, lane, center line, then lane, shoulder, foil slope, ditch, bottom, then back slope, then back to the original ground. Then, intersection. Intersections represent the site of most urban motor vehicle crashes in the United States. The number of crashes at intersections has increased by 14% over 20 years period. In urban areas with high traffic volumes, intersections must accommodate a high volume of turning movements that traverse a large surface area. In this situation, channelization is an effective traverse to improve safety. Types of lane dividers used for intersection channelization are raised reflectors, painted lines, barriers, and medians. And then, increased side radius for removal of obstacles. As you can see, there is a before and after. Lastly, pedestrian facilities. The safety of pedestrians is of great concern to traffic and highway engineers. Efforts to reduce pedestrians and bicycle crashes involve education, enforcement, and engineering measures, as it is the case for motor vehicle crashes. In addition, characteristics of pedestrian crashes indicate that factors related to occurrence include age, sex, alcohol use, time of day, urban and rural area type, and intersection or mid-block causing location. The principal geometric design elements that are used to improve pedestrian safety are sidewalks, overpass or tunnels, raised islands, auto-free shopping streets, neighborhood traffic control to limit speeding and through traffic, curb cuts that assist wheelchair users and pedestrians with baby carriage, and then shoulders that are paved and widened.
Common types of pedestrian crashes. We have 6 common types. The first one is dart out. The second, intersection dash. The third, bus stop. Fourth, multiple threat. Fifth, vehicle turn or merge. And the last one is walking along roadway. 3 types of safety strategies. Crash prevention or before the crash. Crash injury and fatality mitigation or during the crash. And lastly, improving emergency response and medicine or after the crash. Some crash prevention strategies. Commercial driver testing and licensing. Drunk driving limits and enforcement. Speed limits and speed limit enforcement. Standardization of traffic control devices. Improvement of roadway geometric designs. Managing direct access to land from arterial roads, aircraft safety regulation and inspection, post-crash investigation and analysis of crash, camera enforcement of speed and red light running, and the last one, road condition and weather. Emergency response strategies. Improved crash, fire, and rescue capabilities at airports. Training and certification of emergency medical technicians. Video surveillance of high crash locations. Pre-positioning of emergency response vehicles. Mayday systems on motor vehicles. The fundamental economics of safety. In terms of traditional economic models, safety is most likely an important part of both the demand and supply functions. The possibility of loss, injury, and death presumably enters travel demand and mode choice decisions, albeit that the profession is still hard-pressed to quantify the exact magnitude of the relationship. Safety also plays a large, if somewhat ill-defined, part of the cost of transportation. The cost of automobiles is inflated by the inclusion of many types of safety-related design features. Commercial transportation providers invest in higher quality equipment and staff training to reduce the probability of mishaps. The economic importance of transportation. Because of its intensive use of infrastructures, the transport sector is an important component of the economy and a common tool used for development. High-density transport infrastructure and highly connected networks are commonly associated with high levels of development. When transport systems are efficient, they provide economic and social opportunities and benefits that result in positive multiplier effects such as better accessibility to markets, employment, and additional investments. When transport systems are deficient in terms of capacity or reliability, they can have an economic cost such as reduced or missed opportunities and lower quality of life. The impacts of transportation are not always intended and can have unforeseen or unintended consequences. For instance, congestion is often an unintended consequences in the provision of free or low-cost transport infrastructure to the users. However, the congestion is also an indication of a growing economy where capacity and infrastructure have difficulties keeping up with the rising mobility demands. Transportation impacts. The relationship between transportation and economic development is difficult to formally establish and has been debated for many years. In some circumstances, transport investment appear to be catalyst for economic growth, while in others, economic growth puts pressures on existing transport infrastructures and incites additional investments. Transport markets and related transport infrastructure networks are key drivers in the promotion of more balanced and sustainable development, particularly by improving accessibility and the opportunities of less developed regions or disadvantaged social groups. Transportation as an economic factor. This is particularly the case for multinational firms that can benefit from transport improvements in two significant markets. The first one is commodity market. Improvement in the efficiency with which firms have access to raw materials and parts as well as to their respective customers. Thus, transportation expands opportunities to acquire and sell a variety of commodities necessary for industrial and manufacturing systems. And the last one is labor market. Improvement in access to labor and a reduction in access costs, mainly by improved commuting in local scale or those of the use of lower cost labor or the global scale. That would be all.